Hi, folks. We're going to talk a little bit more about light. We're going to talk about the transparent and opaque objects introduction. I was going to do a shadow light lab today, but I've decided you need a little bit more background on those two things. So I'll sign that for tomorrow. So today will just be some questions based on this screencast. So here we go. Light and transparent materials. Light is energy carried an electromagnetic wave. And you know that's both electric and magnetic, hence the word electromagnetic. It is generated by vibrating electric charges. That's what waves energy is vibrations. If those waves strike matter, electrons in the material are forced into vibrations. Again, it's always about those tiny little subatomic particles called electrons. Light vibrates at more than 100 trillion times per second, which is 10 to the 14th hertz. So it has to have a small inertia, therefore electrons. So transparent materials. Light passes through materials whose atoms absorb the energy and immediately remit it as light. Matters that are materials that transmit light are transparent. Okay? Natural vibration frequencies of an electron depend on how strongly it is attached to a nearby nucleus. So how much that pull is on it to a nearby nucleus, to its nucleus. That's how strong the attraction is. So, oh, you can see in the picture there, up here, you have the photon absorbed. You have the electron jumps up to a higher orbit. On this one, electron falls down to a lower orbit. The photon is emitted that way. So you can see it depends on the attraction. Okay, it all depends on the attraction, how strongly it is. So transparency. If transparent, frequency of the re-emitted light passed from atom to atom is identical to that of the light that produced the vibration to begin with. The difference, there's a slight time delay between absorption and re-emission. Speed of light in vacuum is 300 kilometers or 300,000, kilometers a second. In water, it is 225 kilometers a second. In the glass, it's 201,000 kilometers a second. So hence the difference over here that you see it. Here is a little bit of a difference, a little angle difference, okay? And then you can see a big difference right here in the water. Okay. OPEC materials. Actually, did I get all this? Yep, OPEC materials. So you see here, this is transparent, which is see-through. This is translucent, which is sort of see-through, but a little faded. And this is OPEC, not see-through at all. Materials that absorb light are OPEC, so it absorbs it. The light does not pass through it. Vibrations given by light to the atoms and molecules are either turned into random kinetic energy, thermal, reflected back if that part of the spectrum is not absorbed. So OPEC materials. Metals are OPEC, but the outer electrons are not bound to the atom. Okay, so why are they good conductors? So just think, if they're not bound to the atom, think what's happening. These outer electrons absorb and re-emit light. So the reflection, why metals are shiny. So they're sending it back again. Okay. Our atmosphere is transparent to visible light, but opaque to most UV rays, just like most windows. Think of the Earth like a big greenhouse. Okay. UV light and glass. Windows block most UV light. Resonant frequency of the glass is the same as the UV light, so it heats it up rather than transmits it. Okay, so you can see in the picture here, you can see over 96% light transmission. coming on through. It blocks 98% of damaging UV light, okay, sending off in different directions, and less than 1% light reflection, okay? So that is your glass scenario right there. Natural vibration. So we're going to look at a video in a minute. This is what it looks like, what a person would look like without sunscreen. Sunscreen's on this side, without sunscreen on this side. You see that it looks the same while we're looking at it in visible light, but if we look at it in an ultraviolet light, this is without the sunscreen, this is with the sunscreen. So you can see all the damaged skin particles here. Okay, wherever you see those dark dots, that means that's skin damage. Okay, and we know if skin's been damaged, it can lead to skin cancer. Something to be aware of. Electrons in the glass have natural vibration frequency in the ultraviolet range. When the UV hits the glass, resonance occurs. It builds up a large vibration. It hits many adjacent. I'm just going to move this screen so you can see it. It builds up, UV hits the glass, resonance occurs, builds up a large vibration, hits many adjacent atoms, but is not re-emitted as light, but converted to heat. That is why glass is not transparent to UV, but is to visible light. So the light will pass through, but not be damaging UV rays. All right, let's see if we can get this video to play. So if you can't hear the sound, it is music, but it's the pictures that you really want to look at because it's really cool. This is what you look like. Pretty girl. Looks fine. This is what you look like in ultraviolet. Notice all the different colorings. That's ultraviolet camera can show not yet visible changes. So you can't see these to the naked eye, but you can see them in a UV light. Check out the reactions of people when they look through this. Mostly freckles. Look at all those freckles. You can't see them normally. I wonder what my face looks like. Also other stuff. Moles, whatnot. Everyone's born with good skin, pretty much. Baby looks pretty healthy. Kids are a little pretty good. At ages at different. Didn't catch the last word there. So look at the glasses does. It blocks the UV. Pretty cool. So glasses look black, sorry. Sunscreen. Look what the sunscreen looks like. Pretty cool. So now do you believe in sunscreen? It works. Mhm. So pretty cool. What's the lesson here? Put your sunscreen on, summer. Okay. Skipping through. Here we go. Shadows. Thin beam of light called a ray. Any beam of light can be thought of as a bundle of rays. When light shines on an object, some of the rays may be stopped while others pass on in a straight line path. A shadow is formed where light rays cannot reach. Sharp shadows are formed by a small light close to an object or by a large light source far away. So here you have a light source here. Two more terms. It's called the penumbra. That would be this area right here. And the umbra. That would be that area there that stays dark. This part is the light part. Most shadows are blurry. Complete darkness of shadow is the umbra. The partial shadow is the penumbra. A penumbra appears when some of the light is blocked, but where other light fills in. Can happen when one light source is blocked, but another fills in, or where light from a broad source is just partially blocked. Example, a lunar eclipse. So here you have the light source. Here you have the moon. It's doing the blocking. Here you have the umbra, the dark part. Here you have the penumbra. That's the partially lit area. And then you see the partial eclipse visible here. Okay, and this would be the Earth. Right, I think that's all I wanted to talk about today. Oh, no. Hand puppets. Gotta have some hand puppets. Why not? We'll end the day with hand puppets. Shadows. So, if you guys do this lab and you're making some really cool shadows and you can do some cool shadows,